Our space is truly mysterious, right? Every time scientists try to get any specific information, they get new other information from space. They have been really trying to find a life beyond Earth for the past several years. But recently, NASA found out something terrifying entering our solar system. Welcome back to Theory of Science. A brand new interstellar visitor has been discovered, raising a bunch of questions. Let's explore further to learn more about this strange visitor and what it might imply for the future of humanity. Scientists are still interpreting the strange object's messages about planetary systems 5 years after discovering the first known object from outside our solar system passing through space. Many trillions of small bodies could be launched into interstellar space by riding ice giant planets like Neptune, some of which make visits to our solar system like Oumuamua did in 2017. If this is the case, there may be hundreds of billions of trillions of such rogue objects circling the stars. But before knowing more about this, we need to look back into 2017. This cosmic invader, who visited our solar system for the first time with certainty, has the appearance of a stony, cigar-shaped object with a slightly reddish hue. The object, which its discoverers named Oumuamua, is up to 1/4 mile long and extraordinarily elongated, possibly 10 times longer than it is wide. This aspect ratio is bigger than any asteroid or comet that has ever been seen or discovered so far in our solar system. Its unusual, elongated shape may offer fresh insights into how other solar systems developed, despite being highly startling and unlike anything found in our own solar system. According to observations, until it happened upon our star system by accident, this strange object had been roving through the Milky Way for hundreds of millions of years without being connected to any other star system. On October 19, 2017, Robert Warwick made the discovery of Oumuamua using the Pan-STARRS telescope at Haleakala Observatory in Hawaii almost 40 days after it had passed the Sun's closest point on September 9th. The so-called Local Standard of Rest, LSR, which is determined by averaging the random motions of all stars in the solar neighborhood, is the frame of reference from which Oumuamua emerged. In that frame, only one star out of 500 is traveling as slowly as Oumuamua. The LSR is the best frame for camouflaging, namely for obscuring an object's origins and preventing associations with certain stars. The Sun's movement in relation to the SLR is reflected in the movement of the interstellar object. The solar system is like a rapid ship approaching Oumuamua, which is like a buoy resting on the ocean's surface. Despite being so close to the Sun, Oumuamua didn't exhibit any symptoms of a coma. It has accelerated without using gravity, maybe as a result of outgassing or a push from solar radiation pressure. The object rotates at a rate comparable to the typical spin rate of asteroids in the solar system. Yet, several reliable models allow it to be longer than all but a few other natural bodies. The strangest thing that scientists had ever witnessed startled everyone. Typically, when scientists study rocks in space, they come from within our solar system. However, Oumuamua wasn't a typical rock. It had managed to reach the Earth's region from outside our solar system, which is very impossible. The speed of Oumuamua was not slowing down as it approached to Earth, rather it was increasing. Oumuamua would then perform a loop in orbit and return to the general area from where it came from. When the researchers dug deeply into the data they had gathered, they discovered that Oumuamua had sped up not just once as it approached Earth, but numerous times throughout the trip there and back. However, as it's a rock, neither an engine nor blasters are present. Oumuamua, though, was anything but typical. Instead of being a lengthy shard as was first thought, it most likely had the shape of a flattened, disc-like sliver. A relatively similar-looking body has been observed in the form of Arakoth, a Kuiper Belt object that NASA's New Horizons probe passed by on January 1st, 2019. The majority of comets do not resemble Oumuamua or Arakoth. In addition, the characteristic coma or atmosphere that surrounds a comet's primary body was absent from Oumuamua. Even though astronomers were unable to identify any outgassing, the object's acceleration altered as if it were being propelled by comet-like outgassing. Despite unconventional interpretations, scientists prefer the notion that Oumuamua was a piece of solid hydrogen ice. A thick molecular cloud of gas's cold center would have been the only place where such an entity could form. Such clouds give rise to stars when they're gravitationally destabilized, but do you think that they're cold enough to create a chunk of solid hydrogen like Oumuamua? The hydrogen theory said that this object might be formed inside a molecular cloud, and then as time passed, it whittled over. The issue with this idea is that it's extremely difficult to create an atmosphere that is cold enough for molecular hydrogen to freeze out quickly. At approximately 14 Kelvin or 14 degrees above absolute zero or minus 434 degrees Fahrenheit, molecular hydrogen freezes. Similar temperatures can be found in the centers of molecular clouds, but it's unclear how frequently the conditions would need to be ideal for the hydrogen to condense fast into a solid. However, if they are widespread, Oumuamua would have been put together from a formation of stars and planets in its cloud. According to preliminary orbital calculations, the object originated from about the same direction as the brilliant star Vega, which is located north constellation of Lyra. Even at a speed of nearly 59,000 miles per hour, the interstellar object took so long to travel that Vega was not in the area when the Oumuamua was there approximately 300,000 years ago. A similar interstellar object like Oumuamua is thought to pass through the inner solar system around once every year, but they are faint and difficult to detect. Therefore, they have gone unnoticed up until now. Survey telescopes like Pan-STARRS 1 have recently just lately become strong enough to have a chance of finding them. Now do you wonder what Oumuamua means? It's a word adopted from the Hawaiian language and it means a messenger from afar arriving first. Don't forget to like the video if you're liking it so far and subscribe to our channel for more interesting content. There was a constant debate about whether it was a rock, comet, asteroid, or something else. Researchers decided to observe the object through the much larger telescope in Chile. Its mission was to attempt to determine the precise measurements of the object, as well as to go on one step further and determine the color and brightness of its orbit using the data. Now that nothing like this had ever been seen before, it was crucial to record every ridge and detail of the rock. When the specifics poured in, you would expect that things became less muddled, but instead, everything ended up being more confusing. What do you imagine when you think about an asteroid or perhaps a comet? Probably something that's slightly rounded, yes? That's because most celestial objects are spherical, or at least slightly so. The necessity for atoms to be rounder increases even further in open space because of the debris, gases, and pressure present there. Therefore, it's not a random event that all of the atoms in an object are often drawn to one gravitational force, whether it be that of a sun or something else. It was also found that the brightness of Oumuamua varies by a factor of 10 as it rotates on its axis every 7.3 hours, according to a team of astronomers led by Karen Meach of the Institute for Astronomy in Hawaii, who combined images of the FORS instrument into the ESO telescope taken with 4 different filters with those from other larger telescopes. No other known asteroid or comet from our solar system has such extensive brightness variations or a significant length to width ratio. The things that are most elongated we have seen so far are no longer than 3 times as wide. This very large brightness change indicates that the object is highly elongated, measuring almost 10 times as long as it is wide and having a convoluted, complex shape according to Meach. These characteristics imply that Oumuamua is dense, made of rock and potentially metals, lacks water and ice, and that the reddening of its surface was caused by cosmic ray irradiation over hundreds of millions of years. To know more about this, we should wait till the next visit of this interstellar object. Until then, let us know what you think about Oumuamua. If you liked the video, hit the like button and stay tuned for more such content. Check out our channel for more interesting videos like this one, and we'll see you in the next video.